Don't start writing yet. Just pay attention. Okay? First thing I want you to remember is that radicals must be in simplest form, which means under the radical, if there's anything that can be pulled out, you've got to pull it out. And you can't leave the radical in the denominator of a fraction. Fractional exponents are just like radicals. Radicals are just like fractional exponents, correct? Which means, that's not what it means. Which means whatever rules apply to the radicals also apply to fractional exponents. All right, sometimes radical expressions are too hard to work with. Write this down. When radical expressions become too difficult to work with, we turn them into fractional exponents. See, up until now, we've multiplied stuff like this. The square root of 2 times the square root of 4. And since they were both under a square root, I could simply say that's the square root of 2 times 4, right? And I could put it together. But what happens when you're trying to multiply a square root and a cubed root? You can't multiply 2 and 4 together to get 8 because it's not the same root that you're looking for. So we're going to look at how to use fractional exponents to be able to solve things like this. Okay, if I asked you to simplify this, the fourth root of 15 cubed times the square root of 15. All right, now the good thing is that 15s are the same. But the bad news is they're not under the same radical. So how do I deal with them? I turn them into an alternative state. Fractional exponents, because yesterday we learned how to deal with these things. 15 to the 3/4 is the same thing as the fourth root of 15 cubed, correct? Does everybody see that? Blake, do you? Okay. And 15 to the 1/2 is the same thing as the square root of 15. And now we ask ourselves, okay, what am I trying to do here? I'm trying to multiply. So what do I do with the exponents? I have to add them, which means I need to get a common denominator. So I'm going to multiply by adding the exponents, which requires me to get a common denominator, which the common denominator is 4, correct? So it becomes 3/4 plus 2/4, which is 5/4, okay? Notice the 15 has never changed. The 15 is staying 15. All I'm concentrating right now is the exponents. All right, but how did this problem start off? Did it start off with fractions or as radical? It started off as a radical, so we need to put it back into radical form. 15 to the 4/5 as a radical, the 5/4, is the fourth root of 15 to the 5th power. All right. Now, what did we say about radicals? They must be simplified, which means if you're looking for a fourth root and there are 4 under there, what are you supposed to do? Take them out. Remember the little division trick I showed you. Concentrate on the x right now. How many times does this 4 go into 5? Which means you can take one x out. How many are left over? 1. 4 goes into 5 once, with 1 left over. So there's 1 x left in the radical, right? Okay, well, instead of x, we have 15. So we could take 1/15 out, and we have 1 left under the radical. And so now we multiplied those two radical expressions together, and this is what we ended up with. We had a fourth root and a square root, and the answer ended up in a what? In a fourth root. Okay? So what are the steps that you need to look at? If your radicals are too difficult to work with. By the way, those two radicals we looked at, could we ever add them together? Is there any kind of magical trick that we could do to make them alike? No. Fourth root, square root, completely different. You would not be able to add them. Change it into a fraction, change it into a monkey. It doesn't matter. Okay? But for multiplying and dividing, we're going to turn it into a fractional exponent. Then we're going to solve it using the procedures and the things that we learned the other day. Then we're going to put it back as a radical, because how we start is how we finish. Then you're going to make sure that the radical is simplified. Okay. Let's look at 12. I'm asking you to multiply, and these are two completely different radicals. According to the steps I just gave you, the first thing is to take these radicals and turn them into fractional exponents, okay? Hurley, can you tell me what the square root of 12 would become? 12 to the what? No. 1/2. Okay? 12 to the 1/2. Caleb, way back in the back. What would the fifth root of 12 cubed become? 12 to the what? 3/5? Is that what you're saying? Okay. Good. 12 to the 3/5. Okay, well, we did this in the lesson yesterday. What do you got to do? Common denominator, because we're going to be adding 1/2 plus 3/5. What is the common denominator? 10, which means this becomes 5, and this becomes 6. So it's 12 to the 11/10. Okay. What's step 3? Turn it back into a radical. How do you put 12 to the 11/10 into radical form? Parker?
10 radical 12.
Very good. What's step 4 say? Simplify the radical. Do you have enough 12s in there to take one out? Yes. I can take out 1 12. How many do I have left? And this is your answer. 12 times the 10th root of 12. Okay? So the reason we were looking at all those fractional exponents is because it gives us a way to solve crazy radical problems that aren't simple. They're much more complex. All right? Let's see if you can do this one on your own. Follow the 4 steps.